This is the second half of the Unit 8 review. Identify the vertex, then rewrite the following in vertex form. So we want to, well, we can complete the square to do this. So if we factor out a -1 from the first two terms, we'd say -1 times x squared plus 10x, and then leave a little space and leave that 23 or that -23 out there, and say what would we put in here to make this a perfect square. Well, half of 10 is 5, and 5 squared makes 25, so we'd add 25 to this side. Now really we're subtracting 25 because -1 times 25 makes -25, so we want to add 25, so that we're subtracting 25 and adding 25. We're really not changing the equation. But this factors to the quantity x plus 5 squared, and -23 and 25 make 2, and so there's our vertex is -5, 2. And here's our vertex form. 20, the same thing, except for we don't need to factor. What's half of 4 is 2. 2 squared is 4, so this is y equals x squared plus 4x. Put this 8 out here. And what do we add to this? We're adding 4 to it. And so what do we need to do? To the 8, we need to do the opposite of adding 4, so we need to subtract 4 out here. So that's y equals the quantity x plus what's half of 4? 2. That quantity squared, and 8 minus 4 is 4, so plus 4. So here our vertex is -2, 4. 21, same idea, except we're going to need to factor out a -1/2. So y equals -1/2 times the quantity x squared, and then plus 2x, leave a little space, 3 out here. What's half of 2 is 1, 1 squared is 1, so plus 1 here. But really, what are we adding? We're subtracting 1/2, right? So what's the opposite of subtracting 1/2 is adding 1/2. So this is y equals -1/2 times the quantity x plus 1 squared, and 3 plus 1/2. Well, 3 times 2 is 6, plus 1 is 7, so plus 7/2. And so our vertex is -1, 7/2. Last one, factor out a -1. Y equals -1 times the quantity x squared minus 4, plus 4x, because we factored out a -1, and then have that minus 13 out there. What's half of 4 again? 2. 2 squared makes 4, so we're adding 4, but we factored out a -1, so we're actually subtracting 4, so we want to add 4 out here. So y equals -1 times the quantity x plus 2 squared, and -13 minus 4 is -9. So our vertex is at -2, -9. 23. Solve the system of the equations graphically and algebraically. So, well, x equals -b over 2a. This is a perfect square trinomial though too, right? That's y equals, what's half of 6? 3. 3 squared is 9, so the quantity x minus 3 squared. So what's that mean? That means our y-intercept is at, or our x-intercept is at 3, and we're going out from here. So if we substitute it in a 4, what's 4 minus 3? That's 1. 1 squared is 1, so 4, 1, and 2, 1. You got your axis of symmetry here. X equals 3. Sub in another number, how about a 5? 5 minus 3 is 2. 2 squared is 4, so 5, 4. And that would make 1, 4. And you can see your y-intercept from your original equation is 9. So 9, 9. And now our other equation, y-intercept is 5, slope is negative 1. And where do they intersect? There and there, so that's 1, 4 and 4, 1. Algebraically, we're going to write them equal to each other. X squared minus 6x plus 9 equals negative x plus 5. And now we'll put them on let's I'm going to cancel that for right now. We'll add x to both sides, subtract 5, x squared minus 5x plus 4 equals 0. Factors of 4 that add together to make negative 5. Well, what are they? Negative 4 and negative 1. So the quantity x minus 4 times the quantity x minus 1 equals 0. So your x-intercepts are at 4 and 1. And now when we plug in, if we substitute in a 4 in for x into this equation, we already know this when we graphed it. Where were we? At 4. We were at 1. So that's 4, 1. And when we sub in a 1 into that same equation for x, at 1 we were at 4, so that's the 0.14 right here and right there. Same thing for 24. What's half of 2? 1. 1 squared is 1, so this is a perfect square trinomial. So this would be y equals the quantity x plus 1 squared. So what's that mean? Our vertex is at negative 1, 0. If we plugged in a 0 for x, 1 squared is 1, 0, 1, negative 2, 1. We've got our axis of symmetry. And x equals negative 1. We also knew our y-intercept was at 1 because of there. If we sub in a 1 here, 1 plus 1 is 2, 2 squared is 4. So 1, 4, negative 3, 4. We can sub in a 2. 2 plus 1 is 3, 3 squared is 9, so 2, 9, and negative 4, 9, and that's enough. This other equation, y-intercept is 1, slope is negative 2, down 2, right 1, up 2, left 1. Where they run into each other, right there at negative 4, 9. And what is that, 0, 1? Algebraically, we'd write x squared plus 2x plus 1 equals negative 2x plus 1. Set it equals 0, x squared. Oops. Let's add 2x. Let me show you the work. Add 2x, subtract 1, subtract 1. x squared plus 4x equals 0. What would we do? Factor out an x. X times x makes x squared. X times 4 makes 4x. Zero product property says x equals 0. It says x plus 4 equals 0, so x equals negative 4 and 0, right? We're going to sub this back in. Well, we already know that when x is 0, or was it when x is 0, we were at 1, so that was 0, 1. That was one of our solutions. And when x is negative 4, well, negative 4, we're up here at 9. Negative 4, 9. That's our other solution. Negative 4 times negative 2 makes 8, plus 1 makes 9. Oh, more. Alright. Last two. This is not a perfect square trinomial, right? What's half of 4? 2. 2 squared makes 4. So not a perfect square trinomial. So let's do it. X equals negative b over 2a. B value is negative 4. A value is 1. Two negative factors. 4 over 2. X equals 2. Our axis of symmetry. If we sub in a 2 here, what's 2 squared? 4. Negative 4 times 2 makes 8, so negative 8 minus 2. 4 minus 8 is negative 4 minus 2, negative 6. So 2, negative 6. There's our vertex. Take our equation. Y equals x squared minus 4x minus 2. Let's sub in, well, let's look here. We've got a y-intercept of negative 2 here, so there would be there. Let's sub in a 1. 1 squared is 1, minus 4 is negative 4, minus 2. 1 minus 4 minus 2. 1 minus 4, negative 3, minus 2, negative 5. So 1, negative 5 makes 3, negative 5. Let's do another one. How about a 5? Or, what else could we do besides 5? We could do a negative 1. Let's do a 5. That would make 25 minus 20 minus 2. 5 minus 2 is 3. So 5, 3, and negative 1, 3. That's enough. Y-intercept's negative 2. Slope is negative 1. Alright, we can see there it intersects at 0, negative 2. Right here, and what is that? 3, negative 5. And 3, negative 5 algebraically. We'd write x squared minus 4x minus 2 equals negative x minus 2. Add x. Add 2. X squared minus 3x plus 0, so equals 0, so factor out an x. X minus 3. X equals 0 and x equals 3. And we can go back here when we sub in a 0. 0 minus 2 is negative 2, so that's 0, negative 2. Well, that's where our solution was. And when we plug in a 3, negative 3 minus 2 is negative 5. 3, negative 5 right there. 26. Same idea. X equals negative b over 2a. Negative 2 over 1. 2 negatives, it's a positive. 2 over 2 makes 1. X equals 1. is our axis of symmetry. Take our equation, y equals x squared minus 2x minus 2, sub in a 1, 1 squared is 1, negative 2 minus 2, 1 minus 2 is negative 1, minus 2 is negative 3. Is our vertex, 1, negative 3. Y-intercept is at negative 2, so we've got a point there. Let's sub in a 3 next. 3 squared is 9, negative 2 times 3 is negative 6 minus 2. That's 3 minus 2 is 1. So negative 1 as well. Sub in a 4 next. 4 squared is 16. Negative 2 times 4 is negative 8 minus 2. 8 minus 2 is 6. 4, 6, and negative 2, 6. Y-intercept is 2, slope is negative 2, down 2, right 2, sorry, down 2, right 1, up 2, left 1, you can see they intersect at negative 2, 6, and at 1, negative 2. Algebraically, let's say x squared minus 2x minus 2 equals negative 2x plus 2. Add 2x, subtract 2. Hey, what do we have here? Minus 4, right? Perfect square, subtraction sign, perfect square. This is going to be the sum and difference pattern, right? So x equals negative 2 and x equals positive 2. When we sub in our negative 2, we get negative 2, 6. When we sub in our positive 2, we get positive 2, that's 2, negative 3. I can't count. Not 1, negative 3. When we sub in a positive 2, we get 2, negative 3.